Hi there, folks. Today I want to talk about a Leetcode problem called longest substring without repeating characters. Given a string, find the length of the longest substring without repeating characters. So here I'm given a string of A, B, C, A, B, C, B, B. Okay, so it looks like A, B, C is the longest length. Great. Then what happens when you're given a substring with repeating elements, repeating characters? They're all the same. So here's one, because all of them are all BBB, all the same. And then here's a third example where I'm given PWWKEW. Okay, so it looks like, let's see, PW is, let's see, that's 2, because this is repeated. Okay, so then I could do WKE. Yeah, so that's 3 would be the longest substring. And you can't, jump out and get other subsequent characters where it cannot get, P, K, E, W. So it has to be in a substring, which it neighbors. So thinking about this problem, I've had to ask myself, what are the couple things I'm going to need? Well, I think I'll probably would need a kind of like a hash table for looking up each of the character of the given string, and that will kind of dictate um, on whether or not this character has been seen or not. Also, I think having like a slow pointer and fast pointer will help me out because that will tell me what's my max values. So yeah, definitely would need those. And so my logic for my pointer um, system is that I kind of want to move my fast pointer until the fast pointer character has not been seen. So say for example, I start off with this string. I would start my slow pointer at P and my fast pointer at W. Okay, so I've marked those inside my table lookup as been seen. And then once I move my fast pointer to W, it's like, oh, okay, I have seen W already. Um, let's go ahead and bring um, my slow pointer until the pointer at fast pointer. And my fast pointer has not been seen. And as I'm going through, as well, I'm incrementing my slow pointer. I'm also marking each of the characters as I've not been seen. So I would say, okay, I'm going to increment my slow pointer to my next one, and I'm going to mark as P like, okay, P has not been seen because I've, closed my window in a way. And then, okay, W has been seen. So I'm going to go ahead and um, mark W as not been seen. Then once I do that, then um, both my pointers are going to be pointing here. And then I would go ahead and mark my fast pointer as like, okay, you have been seen. And then I would keep incrementing my fast pointer until, the next given string has not been seen. Um, so great. Let's go ahead and walk through this code. So first thing is that I have to take care of all the edge cases. If the string is 0, return it. If the size is 0, return that 0. Or if the size is 1, go ahead and return 1. And I will go ahead and need a table to keep track of each of the characters has been seen. And I will also need to have 2 different max variables. And that's going to be telling me, what's I'm going to be comparing these and seeing, which one has the bigger value. Global max will obviously be keeping track as my, global max. and then my current max, will be as my current substring as I'm iterating through each. And so currently I set my global max as 0, and then my current max is 1. And that's because I'm going to go ahead and have my slow pointer start initially at index 0, and my fast pointer start at index 1. Okay, and then I'm also initializing my slow pointer value as setting as a true. Okay, great. Then I'm also gonna need some kind of loop. So I'm gonna want to keep looping through this string until j is less than the size of the string. Okay, let's look through that. So say I've gone and I've found a character that has been found in my table lookup. Okay, cool. So then I also want to check, setting true and false on the values of each of the string. So pretty much, if it's true, that means it's currently seen on its path. Okay, great. So there's a couple of checks I have to make sure that I get all the edge cases. Well, here, comparing the max values, obviously, if it's the current max is greater than a global max, global max would be the current max. And then, obviously, this code can be refactored in a much more efficient way. But then I was kind of keep checking, if the value of I and j are the same. And for that reason, in my head, it just kind of made sense that, if the values are kind of equal, if they get here if they get here at this value, say like PW, I want to go ahead and set my current max, kind of like a reset, and say like, okay, I'm going to start incrementing my fast pointer. And since I've incremented once, I'm also setting that value as true. So here I go ahead and say my current max is 2. If it's not, then I'm going to go ahead and set my slow pointer as to false. So that's where I kind of ask like, okay, slow pointer catch up to fast pointer, and I'm also going to be decrementing the current max value. Then in this logic, so you kind of see if it's not true, then obviously I'm going to keep moving my j pointer and mark each value as true and incrementing the current max value. Great. And then this other check, I'm also going to be doing the same. If it's the value, if it's not inside the table lookup, I'm going to go ahead and increment my fast pointer, and also incrementing the current max value. And then outside of my while loop, I'm going to go ahead and return the max between my current max and global max. So yeah, so obviously, this code can be improved much more better. There were a couple of edge cases where I had to, check, but I think this would handle all correctly, right? Thank you.